This is a UL articulate probe used to test if the electrical life part is accessible or not. It is specified in several UL or CSA standards in North America. When I develop light fixtures with UL 153 and UL 1598 or CSA 250.0, I use this tool quite often. I think it might be used in IEC European Standard too. I can find the drawing from the internet. It is same as specified by the UL standard. This will be used for creating the 3D model. Let me start with FreeCAD to see how to get it done. Create a new file in the Part Design Workbench. Create a new body, rename it as Main. Create a new sketch on XY plane. Draw an arc at the top. Radius is 3.5 millimeters. Use the line tool to draw the center part of the shape as the drawing at the right-hand side. Select the arc and the line, apply Tangent tool. Define the vertical distance for 3 nodes. (78 millimeters). (97 millimeters). (234 millimeters). Then define the horizontal distance from the y-axis to the nodes. 8 millimeters. (12.7 millimeters). Create revolution. Create a new sketch on XY plane. View section. Draw 3 circles on y-axis. Box select them. Define diameter as 5 millimeters. Define the vertical distance as 30, 60, and 100 millimeters. These are the holes for the joints. Rename the sketch so I can tell which is which when I use it to apply Pocket Tool later. Create another sketch on XY plane. View section. Get external geometry of top two circles. Draw two circles with 7 mm diameter. I didn't use dimensioning on the go as it can easily snap to the existing circle as they are close in size. Rename the sketch. Create new sketch on XY plane. View section. Get external geometry of top two circles. Draw two hexagons. Define the distance between these points as 6 mm. The other one is 8 mm. Rename the sketch. Create new sketch on XY plane. View section. Get external geometry of the third circle. Draw a circle with 7 mm diameter. Rename the sketch. Create new sketch on XY plane. View section. Get external geometry of the third circle. Draw a hexagon. Define the distance between these points as 8 mm. Rename the sketch. Select the sketch holes, apply Pocket Tool, select through all and symmetric to plane. 3 holes are created for screws. Select sketch 1 screw, change the position Z to 2 mm. Select the sketch again and apply Pocket Tool. Select reversed and through all. It is to create the space to recess the screw head. Select sketch 1 nut, change the position Z to -2 mm. Select the sketch again and apply Pocket Tool. Select through all. This is to create the space to recess the nut. Select sketch 3 screw, change the position Z to 7 mm. Select the sketch again and apply Pocket Tool. Select through all and reversed. Select Sketch 3 nut, change the position Z to -7 mm. Select the sketch again and apply Pocket tool. Select through all. Create a new body for a new part handle. Create new sketch on XZ plane. View section. Draw a circle 50 mm diameter. Rename the sketch. Change the Z position to 100 mm. Create new sketch on XZ plane. View section. Toggle to construction line. Select center rectangle. Make a rectangle 25.4 mm by 78 mm. Toggle to normal line. Create two center arcs. Make it radius 25 mm. Select the other arc and make them equal. Select the arc and the line and apply tangent tool. Same for other arc. Draw horizontal lines to join two arcs. Rename the sketch. Change the Z position to 154 mm. Select these two sketches and apply additive loft. Create a sketch on YZ plane. Get external geometry. View section. Create a rectangle width 10 mm, height 12.7 mm. And snap to the Y-axis. Snap the rectangle to the top of the handle. Apply Pocket tool. Select through all and symmetric to plane. Hide the body main. Create new sketch at the body handle. Select XY plane. Get external geometry. View section. Draw a circle at the intersection of the line and the y-axis when the symmetric sign appears. Diameter 7 mm. Apply Pocket tool. Select through all and symmetric to plane. Show the body main. Switch to Part Workbench. Select the body's main and handle. Apply Union tool. Switch to Part Design Workbench. Create a new body. Rename it as Probe. Move the fusion to the body probe. Create a sketch under the body probe. Select XY plane. View section. Use polyline to draw the shape as the drawing at the right-hand side. Define the vertical distance of the nodes. 5 mm. $90 mm. 100 mm. 136 mm. 234 mm. And then define the horizontal distance of these nodes from the y-axis. 2.9 mm. $7.5 mm. $9.5 mm. This one should be 95 mm, not 100 mm, correct it. Horizontal distance is 10.75 mm. Get external geometry. Snap this point to the handle. Select all the lines. Click Symmetry tool. And then select the y-axis. Lines are copied as mirror image. But the line does not snap at the origin. Apply coincident to these 2 points. Make the corresponding mirror image points symmetric. Select 2 points in the y-axis, click Symmetric. Same for other points. Draw a rectangular shape to enclose these lines. We'll use it to trim the cylindrical body created before. Make 2 vertical lines symmetric. Define the length of the lines as long as they are long enough to enclose the shape of the probe. The node at 154 mm is missing. Delete these 2 lines. Use polyline to draw the lines again. Vertical distance is 154 mm. Horizontal distance is 12.7 mm. Select these 2 points in the y-axis, symmetric. Close the sketch. Apply Pocket Tool, select Probe as the active body. Click OK. Select Through All and Symmetric to Plane. Turn the probe so the holes are facing left. Switch to Part Workbench. Select Create Primitives from the drop-down menu. Plane is at the first place of the drop-down menu, so no need to change it. Use 30 for both length and width for the plane. Click Create button twice. Then change width to 10 and create one more plane. Close the window. Select the first plane and left-click the mouse to get the transform tool. Set rotation increment to 90 degrees and the translation increment to 10. Rotate, move the plane. Same for plane 001. Move the plane back to form a Z shape. Select these three planes and duplicate. Use Union tool to combine the planes. Select Fusion, right-click the mouse to get the Transform tool. Change translation increment to 35, move the plane downward. So the center of the plane will be 30 mm from the top. It is the position of the first joint. The drawing doesn't specify the size of the joint, I make it 10 mm. There is a gap of 0.05 mm. However, with my 3D printer, I cannot get this resolution. So I just cut it without leaving any gap. It should be fine as long as I can rotate the probe and it is not too tight. Select plane 005, change width to 20 mm, which is the size of the third joint. Move the top plane up by 10 mm to match the vertical plane. Select plane 004 and change the width to 12.7 mm. Select plane 003, make a duplicate. Rotate and move plane 006 by 90 degrees. Change the increment to 12.7 mm and move the plane horizontally. Change the increment to 20 mm and move the plane down to match the small horizontal plane. Select plane 003, 004, and 005 and make duplicate. Select planes 003, 004, 005, and 006. Apply Union. Select Fusion 002 and right-click the mouse to get Transform tool. Then change the increment to 110 mm and move the planes down. Now the center of the plane is at 100 mm position, where is the third joint. Then change the increment to 5 mm, move the plane to cut the probe entirely. Same for the second plane. Select plane 008 and change the width to 30 mm. Select plane 009, change the width to 14, which is the size of the middle joint. Then change the increment to 6 mm, move the top plane down. Change the increment to 5 mm and fix the position of the top plane that I messed up before. Move the horizontal planes to form a reversed Z shape like the drawing at the right. Select plane 007, 008, and 009, apply Union tool. Select Fusion 003 and get the Transform tool. Change increment to 67 mm and move the plane down. Select the second plane and get the Transform tool. Change the increment to 5. Move the plane horizontally to cut the probe completely. Position of these planes are good and ready to slice the probe. Select the body probe, Fusion 001, 002 and 003. From Part drop-down menu, select Split and then Slice Apart. The probe is sliced into 4 parts. Switch to Part Design Workbench. Create new body under the existing file. Create 4 bodies and rename them as top, middle, bottom and handle, base. Move the sliced parts to the bodies as I need to edit them further. Hide the body's middle, bottom, and base. Make the body top the active body. Select the bottom edge at the right and apply Fillet tool. Radius 5 mm, which is the size of the first joint. Hide the top and make body middle active. Apply fillet to the top edge, radius 5 mm. For the edge at the bottom, apply fillet of 7 mm, it is the size of the second joint. It looks good. Hide the body middle and make the body bottom active. Select the edge at the top, apply fillet tool, radius 7 mm. Select the edge at the bottom, apply fillet tool, radius 10 mm, and this is the third joint. Hide the body bottom and make the body handle base active. Create a sketch in body handle. Select XY plane. View section. Get external geometry of the circle, top and side edges. Draw and center arc to touch the top and side edges. Snap the point to the top edge. Snap other end to the side edge. Snap the top point to the y-axis. Draw 4 straight lines to enclose the corner. Define the length of lines so they are at the outside of the body. Select the sketch and apply Pocket tool. Select Reversed and Through All. Switch to Assembly Workbench. Create new assembly. Hide the body handle base. Insert component. Insert all 4 components. Select the handle and ground it first, as at least one component must be fixed. Select Revolute joint icon. Select holes at the bottom part and the handle. Click OK to complete the joint. Same for the middle and the top parts. The probe is fully assembled. Rotate the parts to see if there is any interference or not. Everything looks fine. Hide the assembly. Export all the parts as STL file, which is for 3D printing. Open the STL files to double-check if they are okay or not. All look good and I can make the 3D print now. Print the components by my Bamboo Lab A1 printer. It takes about 2 hours. Remove all the supporting structure first. Put a nut at the top part, fix the middle part to it by machine screw. Then use nuts and screw to complete other 2 joints. When I develop light fixtures, I use this tool to check if electrical life parts are accessible or not when there are openings at the enclosure. This tool can be used for reviewing a design or prototype before you send your product to UL or CSA for certification. However, if your company is qualified to do the test for formal UL or CSA certification, then the tool must be calibrated. So you have to buy one with calibration certificate. If you find this video interesting, please subscribe and give it a like. Thank you for watching.